Welcome to Discovering. White nose syndrome has certainly taken its toll on the bat population. Tonight we'll go underground with a research team for a bat update.
We would have to use trillions of dollars more in pesticides to control insect populations if bats weren't around.
Stick around, that's all tonight, right here on Discovering.
The secret streams that flow beneath the cliffs of colored stone. Forest thick and healthy with birch and pine and oak. Surrounded by the greatest lakes this world has ever known. The black bear's awesome presence as he roams the hills and fields. Call of the timber wolf, the loon's lonesome trill. The eagle soaring high above, the trout lies deep and still. These are what I treasure, the only way I measure feelings that I have for this fine land. There is so much to discover when you're a long-time lover of northern Michigan.
This abandoned mine was once home to over 20,000 hibernating bats. Now only a small number hang from the cave ceiling. The effects of white nose syndrome on bats has taken its toll. How many are left? Is there yet a cure? I once again joined a team of researchers on a mission underground for an update on this continuing story.
You know, we're excited to be here today. We're at the Norway site, the Norway mine, working with Dr. Tim Carter and Dr. Martin Vonhoff from Western Michigan University and Ball State University. They're looking at white nose research that's looking very promising. Field trialing the use of chitinase as a treatment for bats that are infected with white nose. And Michigan and Wisconsin and several other states are piloting these research projects across the country. And in this particular one, we've been looking where we have a exposure on these bats. Within the mine site, the bats are treated, and they're coming back now in the springtime to evaluate what happened over the winter time. Normally what we're seeing is mortality, significant mortality in these sites. And we're hoping that this treatment can abate the mortality and we'll have less loss of bats.
White nose syndrome is a fungal disease that's killing bats across the US and Canada. In fact, they found it in Europe and Asia as well. Here in North America, it's led to absolutely massive population declines. Estimates probably somewhere between 10 and 15 million bats have died in North America so far since the disease was first discovered in 2006. And so, of course, anybody who studies bats is doing everything we can to understand everything we need to know about the biology of bats that's relevant to the disease, about the biology of the disease organism itself, and of course how bats then respond to that disease. And then a number of us are trying to pursue various treatment options to see if we can slow or minimize the impact of the disease on bat populations.
Really? Yeah, it looks okay. Wow. Yeah, that's a miracle. We do have a sign on it too. She took a slightly different path, but she did very well.
This site originally had over 20,000 bats in it prior to white nose arrival 4 years ago, and now we're down to several thousand. So it's important that we try and find some kind of solution to this disease. This disease is persistent in the environment, and in many cases, in many areas, you know, the population's crashed almost to zero. This is a colder site. So what we find is in the colder sites, the bats do a little better than they do in the warmer sites. The fungus grows more quickly and more completely in the warmer sites, and it seems to have a much higher mortality rate with the bats. In this particular site, we have big brown bats. and we have little brown bats. We used to have northern long-eared bats, which is a threatened species because of white nose syndrome, but most of those animals have actually already perished because of the disease, so there's very few of those, if any of them, left in the site. Occasionally you might pick up a tricolored bat in the site, but again, those species have probably already perished because of the disease. They're the most susceptible to the disease, and they're probably already gone from the site. We don't find hardly any of them left in the range in the Upper Peninsula anymore because most of them have already died.
You know, we're doing a study where we're testing a potential treatment for white nose syndrome. We have a series of sites here in the UP, some of which are control sites, some of which are treatment sites where we actually use the compound that we're testing, and the compound we're testing is called chitosan. Chitosan comes from the exoskeletons of arthropods like shrimp and crabs and lobster and insects, and it's been shown to have an antimicrobial effect, so it acts against the fungus and actually kills the fungus that causes white nose syndrome in bats, and it helps heal the wounds that the bats get in their skin, so on their wings, on their muzzle, and on their ears. So we're at a site here that was a treatment site, so we sprayed the bats with chitosan. And back when we were here in the fall treating the bats, we took a swab from every bat, and we take multiple swabs, in fact. One is to get an idea of how much fungus is on the bat. One is to get an indication of whether the spores on the bat are still viable, which means can they still grow. And then we also take swabs to look at the overall microbiome of the bats, so all of the bacteria and fungi that are growing on the skin of bats, to see whether the treatment changes that and whether white nose syndrome itself changes that. We did that in the fall. We come back in the spring after bats have gone through most of hibernation, and the idea is to see, okay, well, how many bats are still alive at the end of the experiment in both our control and our treatment sites, and has the amount of fungus on the skin of the bats changed? And so we're swabbing bats again to get that indication. We do the microbiome swabs again to see if their microbiome has changed across the season. We're actually helping out another study that's doing some work with the fungus that causes white nose syndrome, so we're taking some extra swabs for them, and we take a picture of their wings with UV light. And what we found is that the fungus that causes white nose syndrome fluoresces orange under long wavelength UV light. So if we take a picture, we can actually quantify how much fungus is on their wings, and it gives us another indication or an independent verification of what we find with the swabs that we take.
So this is a picture of the first bat we just did, and you can see there's a little bit of fluorescing there, not too bad. And then this is the second one we did, and that one has a lot of fluorescing on it, which is an indication that it could have a lot of white nose syndrome growing on its wings.
So we're here to do this for 20 bats at this site, and then we're going to open the site up and come back again next fall and do it all again and see if this works over multiple seasons. So when you look at hibernating bats, they are found in places that are really cold, and they have to be really, really humid. Because bats hibernate because there's no food for them. They eat insects, and starting in the fall then, there's no insects for up to 6 months here in the Upper Peninsula. So they go into a place where they can slow their body temperature down. Bats let their body temperature fluctuate with the temperatures around them. So this cave here is probably at around 38 degrees, 40 degrees, something like that. And the bats then are at that exact same temperature. And that means that their metabolism has slowed down. Their heart is beating maybe 2 or 3 times per minute. Compare that to when they're flying around, their heart is beating probably 2,000 or 3,000 times per minute. When hibernating, bats will breathe in spurts, so they'll take 2 to 3 breaths, and then they won't breathe again for 2 or 3 hours. Then they'll take a few breaths, and then they won't breathe again for another 2 or 3 hours. So completely slowed down. And they do that because there's no energy, there's nothing for them to eat, and there's no water for them to drink. And so they pick these humid sites then. You'll see that many of the bats have droplets of water in their fur, and that's a really good thing for them. It means that they've got water condensing on their fur, and if they wake up a little bit, they can actually drink some of that water and make it through the winter. Since the disease arrived here in North America, that somewhere around 95% of little brown bats have died in affected populations. It's even worse for northern long-eared bats. Their mortality rate is around 98%. Tricolored bats, mortality rate of around 90%. The endangered Indiana bat mortality rates average around 70%. You know, nature all goes together, right? It's all about interactions. And so you start taking, you know, one group of organisms out of the picture and everything changes. And so as you can imagine, you know, take 98% of the population of bats and just wipe them out. This has huge impacts. It has impacts on the predators that normally eat these bats, insect populations that these bats eat. That includes forest pest species, it includes agricultural pest species. And people have done studies where they look at, you know, what bats are eating and how many insects per night they eat. And if you kind of do the math and you scale that up, the economic impact of bats is in the trillions of dollars. So we would have to use trillions of dollars more in pesticides to control insect populations if bats weren't around. So think of the outcome of white nose syndrome. You've got bat populations crashing all over the place. That means they're not eating those insects. And so one of the biggest future impacts of white nose syndrome in bats for humans is that it's going to affect our agriculture and our ability to grow crops. Understanding how this disease affects bats, understanding how we can help bat populations is really, really important for anybody who's interested in the environment, for nature, for functioning ecosystems. Since 2006, it was first found in the state of New York. It's kind of spread out from there. Initially, it actually bypassed Michigan. It went north of us and south of us. But in 2013, I believe, it was first found in Michigan. And since then, pretty much every site here in the Upper Peninsula has been found to be infected with the fungus. And so we're doing work up here. We're treating some sites. We're not treating other sites. We're trying to look at whether our treatment is effective. There are other people doing research here in the UP, also either just monitoring bat populations over time or trying out other treatments as well. And of course, all of this is a big, massive effort to see if we can keep bat populations alive.
You know, the unfortunate part coming here today is we found out that someone has compromised the gate. And these gates are built to keep people out because these are dangerous sites. These are also privately owned sites in many cases. This site is privately owned, and Keweenaw Lands has the mineral rights here. And you know, the gate is designed to let the bats come and go freely, but to protect the public. And we've had issues here in the past with people who've sawed the bars and broken into the site. And we come here this morning again to find someone has done that. They've taken some of the security cameras we have installed at the site. They didn't take all of them. So we have some pictures. They took some of the signs, no trespassing signs, vandalized the site, disturbed the bats, which is the worst part that they've done. They've compromised the study, which is really confounding because this is important work at a national scale that may find a solution, hopefully, for this disease, which is devastating millions of bats across the continent. So have someone come in here and for whatever reason compromise that it's very frustrating and it's very saddening because, you know, most people in the state of Michigan, most citizens, especially in this area, value the bats. They understand these bats eat lots of insects that cause us problems, and they're important to have in the ecology, have them out in the environment. So for someone to come in here for whatever reason and disturb them in the wintertime when they're most vulnerable, when they're in hibernation, is very sad.
You know, I have to have a guy come out with a welder. Oh, yeah. Come all the way back down. You know, by the time I pay for him to do it, it's a $1,000 adventure.
Their disturbance in that site will cause these bats to die, in essence, because that extra disturbance causes them to burn up their energy reserves even faster, and they have very little energy reserves because of the disease to begin with. So this will probably cause some significant mortality in the site before spring finally arrives. So we're hoping to put the word out. So if anybody knows anything about someone who broke into this site this winter, they can call the RAP line, the 1-800-REPORT-ALL-POACHING line, contact the local authorities in Norway, and we'll hopefully have some suspects and be able to make a case and prosecution out of this.
In recent times, you may have heard the term Oak Wilt. I met with MSU Extension Forester Bill Cook to learn more about what it is and what it does.
This is a kind of resource that we're trying to protect. This is an oak woodland. It's a combination of northern pin oak and northern red oak, a little bit of white oak. What these trees do, in addition to provide all the usual forest habitat for structure and wildlife, is the hard mass, the acorns, the food that deer, turkey, squirrels, and other species use heavily during the fall and into the winter. There's only two groups of trees in the UP that produce this hard mass, beech and then a group of oak species. And the beech is toast, or it soon will be, from beech bark disease. Oak wilt on the other hand, is killing mostly these northern red oaks and northern pin oaks. White oaks are a little less vulnerable to this particular disease. Now, oak wilt is a fungus, and one of the principal vectors is people moving firewood. So we're pretty doggone sure that the epicenter for the oak wilt in this part of the UP is Shaky Lakes County Park, where folks were coming up from further south in Wisconsin, brought firewood with them, left it on site, and it started from there with oak wilt and gypsy moth and emerald ash borer, beech bark disease, Asian longhorn beetle on the horizon, hemlock woolly adelgid got a foothold in southern Michigan. The list goes on of reasons not to move firewood around. And oak wilt is one of the big ones, and that's one of the principal reasons why we see it so extensive throughout this area. Now, the oak wilt spreads two different ways. It'll travel overland and it'll travel underground. And the overland transmission is through these beetles that come to feed on the sweet-smelling spore mats that the dying oak wilt fungus produces on a dead tree. That's overland transmission. It also spreads underground through the root systems of especially the red oaks, which graft roots together. They interconnect the roots, and so it goes from tree to tree to tree throughout the entire stand until the entire stand is dead. What we look for with the spore pads is we're looking for a crack in the bark, which, you know, well, bark has crack all the time in oaks, but what you're looking for is one that goes all the way down to the wood. And again, you're looking for those bark cracks in trees that had died the previous growing season, because the next spring is when the fungus is going to produce those spore mats and pressure pads and try to attract those beetles to spread the spores. So if you find something that looks like a crack, you can begin excavating that spot carefully, looking for black, oval, almost velvet-like surface. Depending what time of the year you find the spore mat, you might or might not find the pressure pads because they dry up after a while, but they do leave a raised surface. It looks like a wart, and it tends to be a salt and pepper colored thing on the black oval background of the spore mat. This tree was infected in 2017, and what you can see are these brown streaks. That's not diagnostic for oak wilt, but it's highly indicative of oak wilt. So this is a tree that died in 2017. The fungus over the winter and last fall has created this discoloration in the wood that's just underneath the bark. There's a certain smell that many people can detect. Some people think it smells like vanilla. Other people call it a sickly sweet smell. It's not diagnostic, but it's a really good symptom of possible oak wilt that you can detect during the winter. These 17s painted on the tree means that these trees died in 2017, that summer, and they'll produce the spore pads this year, 2018, in the spring, because the oak wilt has killed these trees, so it doesn't have any living tissue to survive on, so it's going to form these fruiting bodies in order to continue its life cycle. These are the trees that are dangerous. These are the ones that if somebody would come in, cut these trees down, take the bolts to camp, and let them sit in season for a year, are going to produce spore pads and spread the disease to oaks if there happen to be oak anywhere near their camp or their house. Essentially, they should be destroyed before the middle of April. Destroyed, either burned or turned into boards or ground into chips or something to dry that wood out sufficiently so that the oak wilt fungus that's underneath the bark of the tree will not be able to produce the spore mats and the fruiting bodies. Now, if you really want them for firewood, you can cut and split them and stack them, but then we recommend that they be tarped. And that tarp needs to be secured tight to the ground so the beetles can't crawl in and out. So that's how we dispose of the symptomatic trees. Now, how do we set up one of these sites for treatment? We find these symptomatic trees, we identify the other trees that have died from oak wilt, and then we go out a prescribed distance from that infected center based on our chart that shows how large those root systems are based on diameters, and sometimes those distances can exceed 100 feet. And all the oaks within that area will need to be removed. So it's not just the trees that show the symptoms or have recently died from oak wilt. It's the other trees that are close by that are dead yet and they just don't know it. This is an example of a root graft. You can see this is a root from one tree, this is a root from another tree, and then they've grafted together. So if this tree had oak wilt, the spores will travel through the conductive tissue into the root, enter the root of the next tree, and that's how that spreads underground. So we need to emplace a good deep 5-foot trench around this infected area to break that root system up and isolate the oak wilt. Well, what we have here is some 10, 12 years after the oak wilt was treated. A lot of it, what you're looking at, is aspen regeneration, which is one of the target species, but you'll also see there's a whole bunch of oak regeneration in here too. Within this large complex of clear-cut areas, there are pockets where oak wilt was treated, it was trenched. Then this whole area was clear-cut and regenerated. So what we have here is a mix of non-oak wilt mixed with a bunch of oak wilt. Within those oak wilt pockets, the stumps died. And outside the treated areas, outside the trench line, we have just regular, more traditional forest management in regeneration of aspen, red maple, oak, pine, and other species. So oak wilt treatment is not necessarily something that stands by itself. You can certainly combine it with other forest management practices to meet whatever objectives you might have on your property. And when we talk about the value of oaks and beeches, and all of those species are under threat right now. We're losing them from 2 exotic species. And what does that mean for wildlife? Well, you know, nuts are an important part of the diet for a wide range of wildlife species. Now, is that a critical food source? Will the deer all of a sudden up and die? Probably not. But I think overall the hard mast will have an impact, but not one that we're going to regret for years and years in terms of wildlife losses.
Well, that's it for this week. Be sure to check out 906outdoors.com, where you'll find the 906 fishing report, TV6 weather, shopping, and more. Thanks for watching, and I hope to see you next week right here on Upper Michigan's very own Discovering.